Hello, welcome back. We are in Chapter 10, Probability, focusing on Lesson 6, Probability of Independent and Dependent Events. And this is the guided practice. So for this first two problems, we're going to decide whether each set of events is independent or dependent. That's all you're doing. Is it an independent or a dependent event? So I'm going to give you a chance to go ahead and figure out numbers 1 and 2. So here's our friend the pause dragon reminding you to pause. When you get done with 1 and 2, press play, and then we'll go over your answers. All right, we're back. A student spins a spinner and rolls a number cube. So we are spinning a spinner. We're spinning a spinner here and rolling a number cube. If I roll the number cube, is that have anything to do with this spinner, or when I spin this spinner, does it have anything to do with this number cube? Like, does the spinner control the number cube in some mysterious way, or does the cube control the spinner in some mysterious way? And the answer is no. They are completely independent of each other. So this is an example of an independent event. Okay, so the first one is independent. Number 2, a student picks a raffle ticket from a box and then picks a second raffle ticket without replacing the first raffle ticket. So you remember when we talked about the key words were without replacing for a dependent event. So this is totally dependent on the first one. So this would be an example of a dependent event. All right. Let's go on to the next one. Number 3 says find the probability of each of the independent events. So it's telling you that it's an independent. Okay, so let's look at the first one. It says picking a black checker from a bag of 6 black checkers and 4 red checkers. Now, my checkers aren't necessarily the same size, and I'm just going to need you to just bear with me on that. So, and they're not really checkers. It's just something I could find to kind of resemble something like it. So, yeah, I'll put this one here. 1, 2, 3, and go ahead and move over there. 4. Okay, so we have 6 perfectly shaped checkers and 4 red checkers over there. So picking a black checker from a bag of 6 black checkers and 4 red checkers, replacing it, that is a key word, replacing it, which lets you know that it's going to be independent, and picking another black checker. So, okay, so what's the probability of picking a black checker? And I'll use black. So probability of picking a black. Okay, so remember, the probability is the favorable. It's going to be the favorable, like how many blacks there are, versus the total. So favorable outcomes over total outcomes. Okay, so the favorable for picking a black would be 1, 2, 3, 4, 5, 6. You can pick any of those 6 and you'll get a black. Over the total would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we just need to reduce that fraction. 2 goes into both of those. So 2 goes into 6 3 times, and 2 goes into 10 5 times. So that means that the probability for picking a black is 3/5. So we randomly picked a black, okay? But then what happens, it says, okay, picking a black checker from a bag of 6 black checkers and 4 red checkers. And then what happens is we replace it and then pick another black checker. So this is the probability of another black checker. It's going to be the same, favorable over the total. Well, how many blacks are there? There's 1, 2, 3, 4, 5, 6. 6 over a total of 10, and then we reduce it to 3/5. Okay? So if we want to find, this is the thing that I think is really cool. If we want to find the probability of picking a black and then another black, all you do is you take the probability of the first one right here, 3/5, and you multiply it by the probability of the second one, 3/5. So we look to cross cancel. We can't do that, so we just multiply across. 3 times 3 is 9. 5 times 5 is 25, which means that the probability of picking a black and then another black is equal to 9/25. All right. Very, very cool. Okay, so this is what I want you to do, ladies and gentlemen. I want you to go ahead and try 4, 5, and 6 on your own. Okay, there's our friend the pause dragon, reminding you to pause your device and show all your work and press play when you get done, and we'll talk about your answers. All right, we are back. Number 4 says rolling a 6 on the first roll of a number cube and rolling an odd number on the second roll of the same cube. So when we roll the cube here, how many different, so rolling a 6 on the first roll. So we're going to say the probability of rolling a 6. Okay, remember it's the favorable over the total. Well, how many 6s are there on this cube? Well, there's only one, right? So that means there's only one option out of a total of, well, there's 1, 2, 3, 4, 5, 6 sides. So there's 6 different numbers. So the favorable for rolling a 6 would be 1 out of 6. Okay, that's the probability for that one. And then rolling an odd number. Now, when we try to roll an odd number after, let's say we roll this and we get a 6, right, the first time, which is what we want. And then the next time we want to say, hey, what's the probability of rolling a odd number? Well, does the second roll have anything, or does the first roll have anything to do with the second roll? No, they're completely independent, okay? So these are independent vents. So when we want to do the probability of an odd number, we need to figure out the favorable over the total. Well, how many favorables are there? Well, 1 is an odd number. Okay, so that's 1. 2 is not. 3 is an odd number, so that's another favorable. 4 is not. 5 is a favorable, so that is a third. And 6 is not. So that means there's 3 favorable out of a total of 6. And then we just need to go ahead and reduce that fraction. So what goes into both 3 and 6? 3 does. 3 goes into 3 one time. 3 goes into 6 2 times. So we end up with 1/2. And so if we want to find the probability of rolling a 6 and then an odd, I just think it's so cool because we just take the probability of the first and then we multiply it by the probability of the second. Boom, there you go. So 1/6 times 1/2. And then we look to cross cancel, but we can't, so we just multiply across. 1 times 1 is 1, 6 times 2 is 12, and there we have it. The probability of rolling a 6 and then an odd is equal to 1/12. So if you got that right, awesome job. Very, very good. Okay, let's go on to the next one. So problem 5 says flipping a tail on a coin and spinning a 5 on the spinner with sections of equal area numbered 1 through 5. Okay, so we're going to flip a coin on this one, right? And we're going to spin a spinner which has 5 sections like that. Hold on a second. Hold on. Just 1 second. I can make this look better. Do 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 do. Oh, how's that song? Do, 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 boom, boom. Okay, so there we go. There's our spinner right there. Boom. All right. Woo! Okay, so there's our spinner. It's spinning around, and here's our coin. So flipping a tail on a coin and spinning a 5 on a spinner. Now, these are completely independent of each other, right? The spinner has no control over the coin, and the coin has no control over the spinner, so they're independent. So let's go ahead and figure out what is the probability for flipping a tail on a coin. Okay, so so the probability of a tail is going to be the favorable over the total, right? So how many favorable options are there? So we have heads or we have tails. There's only one. So there's one favorable, and the total number of outcomes, well, you can have heads or you can have tails, which means there's 2 outcomes. So the probability of flipping a tail on a coin is 1/2. Okay, let's go to the spinner. So we want to, the probability of spinning a 5 is going to be the favorable over the total. Now, how many 5s are there on this spinner? There's only 1, so that means there's 1 favorable, and the total would be 1, 2, 3, 4, 5. There's a total of 5 outcomes. So there's our individual probabilities. Now, if we want to know the probability of flipping a tails and then spinning a 5, what we would do is find the probability of flipping a tails and spinning a 5. We take the probability of the first one and just multiply it by the probability of the second. So 1/2 times 1/5. We always look to cross cancel whenever we're multiplying fractions, and then we just multiply across. So if we can't cross cancel, and it doesn't look like we can. So 1 times 1 is 1 over 2 times 5, which is 10. So if you got that the probability of flipping a tails and then spinning a 5 is 1/10, awesome job. Okay, on to problem 6. Okay, so in problem 6, what we're doing is drawing a 1, 2, or 3 from 9 cards numbered 1 through 9, replacing the card, and then drawing a 7, 8, or 9. Okay, so we have cards that are numbered 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So we want to know what's the probability of drawing a 1, 2, or 3 from 9 cards. So probability of drawing a 1, 2, or 3 is going to be the favorable over the total. Okay, so we want to draw a 1, a 2, or a 3. So that means there's 3 favorable out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 cards. Okay, so then we just need to reduce this fraction. 3 goes into both. 3 goes into 3 one time. 3 goes into 9 3 times. So we're left with 1/3. That is the probability of drawing a 1, 2, or 3. Okay, then what happens is the card, whatever we drew, it gets replaced. And that's the key word that's telling you this is an independent event. Okay, so it gets replaced, and we have, again, 1, 2, 3, 4, 5, 6, 7, 8, 9, except this time they want to know, well, what's the probability of drawing a 7, 8, or 9? So that means our favorable right here would be 7, 8, or 9. So the probability of drawing a 7, an 8, or a 9, it's going to be the favorable over the total. So now there are 3 favorable outcomes out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we're going to reduce that again. 3 goes into 3 one time, 3 goes into 9 3 times, and so we're left with 1/3, which means that the probability of drawing a 1, 2, or 3, and then a 7, 8, or 9 is going to be found by taking 1/3 and multiplying it by, taking this 1/3 and multiplying it by this 1/3, which ends up being 1/9. So that's the probability. So if you got that one right, awesome job. Okay, let's move on to the next page. Okay, here we have it. Okay, so it says there are 4 blue marbles and 2 red marbles in a bag. Okay, so we have 4 red marbles. These are my Minecraft marbles. No, 4 blue. My bad, sorry. 1, 2, 3, 4. Okay, so we have 4 blue marbles and 2 red marbles. Okay, my little Minecraft marbles. They're so cute. They're so cute. The little block marbles. Okay. What is the probability of choosing a blue marble, not replacing it, then choosing a red marble? Ooh, very, very interesting. Okay, there's some key words. It says not replacing it. That is huge. Does anybody remember what not replacing it means? That means that we are now have a problem that is a dependent event. This is a dependent event, okay? So the first thing we want to do is find the probability. What are we choosing first? A blue marble. So what's the probability of choosing a blue marble? Okay, well that's found by the favorable over the total, right? So we randomly pick a blue. So how many favorables are there? There's 1, 2, 3, 4, right? So it's going to be 4 over the total. There's a total number of 1, 2, 3, 4, 5, 6. So that's going to end up being 4, 6, and we need to reduce that fraction. What goes into 4 and 6? 2 does. 2 goes into 4 2 times. 2 goes into 6 3 times. We're left with 2/3 as the probability. Okay? So we randomly pick out a blue one the first time. Okay? And we don't replace it. It is gone. What is the probability of now choosing a red? So the probability of choosing a red is going to be found by the favorable over the total. So how many favorable outcomes are there for picking a red? Well, there's 1, 2. And over the total, 1, 2, 3, 4, 5. Okay, perfect. So now we just need to go ahead and figure out the probability of picking a blue and then picking a red. Okay, so I love this part. This is my favorite. We just take the probability of the blue and then multiply it by the probability of the red. Boom, boom, boom. So the probability of the blue is 2/3, and we're going to multiply that by the probability of the red, which is 2/5. So we always look to cross cancel whenever we're multiplying fractions, and there's nothing that cancels out. So then we just multiply across, and we end up with 2 times 2 is 4 over 3 times 5 is 15. So the probability of picking a blue and then a red is 4/15. All right, perfect. Okay, let's go on to the next problem. It says that Trinity has 4 $1 bills, 2 $5 bills, and 3 $10 bills in her wallet. If she randomly chooses 2 bills from her wallet, what is the probability that both are $5 bills? Okay, so we first need to figure out, well, what's the probability of picking a 5? That's found by the favorable over the total. Okay, so what's favorable? How many $5 bills are there? Well, there are 2 $5 bills. So that means that there are 2 favorable over a total of 4 plus 2 plus 3, right? 4 $1, 2 $5, and 3 $10 bills. So 4 plus 2 is 6, plus 3 would be 9. And then we look to reduce that, but we can't, so that's it. So if she randomly chooses 2 bills from her wallet, so that's the first bill. What is the probability that they're both $5 bill? So the next bill, this would be the next 5. What's the probability of the next 5? The next 5, that's a 5. The next 5 is going to be found by the favorable over the total. Okay? So we have already picked out a 5. So that means one of the 5s are now gone because we picked it. This is our first pick, and this is our second pick. Okay, so first pick probability and second pick. So there's 2 $5 bills, right? So we picked one of the $5 bills in this first pick. So that means one of these $5 bills is now gone, which means for the next pick, how many $5 bills are left? There's only 1. So that means there's only 1 favorable out of a total of, well, it would be 4 plus 1 plus 3, okay? Because we took one of those $5 bills in the first pick, so this is only a 1 now, okay? That's only a 1. So it would be 4 plus 1, which is 5, plus 3, which would be 8. So for the second pick, if you were to pick a 5, again, it would be 1/8 of a chance, or the probability would be 1/8, okay? So now we want to figure out the combined probability, and this is my favorite because we just multiply these together. So what's the probability of picking a 5 and then a 5? Well, we take the probability of the first, which is 2/9, and just multiply it by the probability of the second, which is 1/8. Now, whenever we're multiplying fractions, we always look to cross-cancel first. And can we cross-cancel anything? Yes, there's a common factor of between 2 and 8 of 2. 2 goes into 2 1 time, and 2 goes into 8 4 times, and then we just multiply across. So 1 times 1 is 1, and 9 times 4 is 36. So that means the probability of picking a 5 and then another 5 is equal to 136. All right. Very, very cool. Okay, so for 9 and 10, I want you to try those on your own, okay? So go ahead and pause, work out 9 and 10. When you get done, press play and we'll talk about the results. All right, we're back. Let's talk about 9 and see how you did. It says there are 10 true-false questions on a test. You do not know the answer to 4 of the questions, so you guess. What is the probability that you will get all 4 answers right? Okay, so I'm just gonna, there's 4 questions. I'm gonna take this question by question. So let's go ahead and figure out the probability of the first question. So probability of question 1, I'm gonna call it Q1, okay? So is gonna be favorable over total. So the first question is true or false, right? So there's going to be an answer, right? And either true or false is going to be right. We don't know, but we just know that out of true and false, there's going to be 1 favorable. And there's a total of 2 outcomes because you can either have it be true or false, and that's 2. Okay, so that's the probability for getting the first question right. The probability of getting the second question right, favorable over total. Again, we don't know what the answer is, but we know that it's either going to be true or false. So the favorable is it's either going to be one of those, right? Out of the total, which is 2. Okay, so that's the probability for the second question. What about the probability of the third? Favorable over the total, right? Again, we don't know if it's going to be true or false, but we do know that the correct answer is going to be one of those. So there's going to be 1 favorable over 2 outcomes. the total is 2. And then lastly, for question 4, favorable over total, it's the same type of question. There's true or false, one answer is going to be right, and there's a total of 2, right? So if we want to figure out what's the probability of getting question 1, question 2, question 3, and question 4 right, we're just going to take the probability for each one of those and multiply them by each other. I love this. So we just take 1/2, multiply it by 1/2, multiply it by 1/2, and multiply it by 1/2. Okay? We could look to cross cancel here. There is a possibility for all types of cross canceling, but there really is nothing to cross cancel because everything's a 1 on top. So then we just multiply across. So 1 times 1 times 1 times 1 is 1. And 2 times 2 is 4, times another 2 would be 8, times another 2 would be 16. So that means the probability of getting question 1, question 2, question 3, and question 4 correct is 1/16. If you got that one right, awesome job. All right, let's go on to number 10. Number 10 says there are 12 students in the after-school club. 3 names are being selected at random to help with the school carnival. What is the probability that Jess, Sandy, and Phil will be chosen? Okay, so there's 12 students, so that's our total. 3 names are being selected at random to help with the school carnival. What is the probability that Jess, Sandy, and Phil will be chosen? Okay, so let's look here. Okay, so what's the probability? So on the we'll divide this into pick because there's selections, right? So there's first selection. There's second selection. And then there's going to be a third selection. Okay. So on the first selection, what is the probability of picking Jess, Sandy, or Phil? Okay, so we're going to find that by taking the favorable over the total. So how many favorable are there? Well, there's Jess, Sandy, and Phil. That's 3 over a total of 12. Okay, then we just need to reduce this. What's the common factor between 3 and 12? It's 3. 3 goes into 3 one time. 3 goes into 12 4 times. So we end up with 1/4. Okay, and what this means is that one person was selected. One of these 3, Jess, Sandy, or Phil, we don't know which one, but one was selected here. Okay, one was selected. That's what we know. Okay, so when we go to the second selection, all right, we're doing the second selection here. We want to find the probability of Jess, Sandy, and Phil is going to be the favorable over the total. We know that one of these 3 people were selected. We don't know which one, we just know one of them. So that means there's only 2 of them left because one of these 3 was selected in this first selection process. Okay, only 2 are left. And the total is different because one person was already selected. Now, instead of 12 students remaining in the pool, there are 11 people. And so, yeah, so that would be our probability. And so what's key on this one is that there was another person selected here. Another one of these were selected. Another was selected. Okay, so then we go down to the third selection. We're going to find the probability of Jess, Sandy, or Phil. And it's going to be the favorable over the total. So since one of these three people were selected in the first selection and then another one was selected in the third, that means for favorable, there's only one person left that would be favorable to be selected. And that means that there's also one less in the total, right? So there was 11 in the last selection. When another person was taken out, one of those people were taken out because they were selected, which means there's only 10 people left in the selection. Okay, so yeah, so now we're actually ready to go ahead and figure out what that probability is. So the probability of Jess, Sandy, and Phil all being selected, you just go ahead and you take all of those probabilities and you just multiply them together. So we're going to go 1/4 times 2/11 times 1/10. And whenever we are multiplying fractions, we always look to cross cancel. So is there anything we can cross cancel here? I would say yes. There's a common factor between 2 and 4. And because this is being multiplied by 1/10, that's okay. So there's a common factor of 2. 2 goes into 2 one time, and 2 goes into 4 2 times. And then we just multiply across. So 1 times 1 times 1 is 1. 2 times 11 is 22. And then it's multiplied by 10, which is awesome because you can just put a 0 on the end of it. So it's 22 and then add a 0, and there you have it. There's the probability for all three of them being selected. Okay, if you got that one right, awesome job, and we will see you next time. Goodbye.